All right, hello everyone. Welcome to today's webinar. We're going to be talking about SPV mainly today. And this webinar is mainly targeted towards the Bitcoin Association Hackathon. So hopefully we'll have most of the attendees who are also signed up for the hackathon. And the plan is to try and answer as many questions as we can, try and fill in a lot of gaps to try and get the best hackathon entries as possible. So please try to ask questions and be as active as possible in the chat and interact as much as you can. So basically, I gave a DevCon presentation around the SPV a few weeks ago. So if you haven't seen that one, please do go watch it. So I'll try not to repeat a lot of the stuff that we already gave in the previous DevCon, but there will be some concepts that are similar. And this talk will be recorded, but please try and be as active as possible. This is mainly for the attendees. So try and basically ask a lot of questions so we could see what level the audience is at, so that we could focus there. So anyway, let's begin. So basically, SPV is not something new. It's been there from the beginning. It's in the Bitcoin white paper, and it's basically the only way to properly scale Bitcoin. So with scaling Bitcoin, we've got two main sort of aspects. We've got the nodes on one end, and we've got the users, and that's been clear since day one from the Bitcoin white paper and Satoshi's early messages. And primarily, everyone's been focused on scaling the nodes, which are the miners, but there has been little work put into the users, which constitutes a huge part of the network. And we've seen many times where the users have not been properly prepared, and then as soon as the Bitcoin nodes, the network has a lot of traffic, a lot of the users start falling over because they haven't built things with scale in mind and done properly. And the only way to do it properly is using SPV. So we've done a lot of research around all types of different ways to scale blockchains. A lot of research has been done with other different projects, like Lightning Network on Ethereum, zero knowledge proofs, rollups, all that kind of thing. But those are different methods to try and scale the blockchain, but they just skip the first step entirely. And we're focused on scaling on chain, and that's how you can do it with SPV. So in this, I'm sure you guys have already heard a lot of the stuff, but in this presentation, we're going to try and focus mainly on SPV, peer-to-peer payments, and then how the users interact with the miners. So let me just start with answering a couple of the questions. So a link to the DevCon presentation, we'll send that to you guys afterwards for sure. And what is the best way to get the block headers? So that's also covered in the DevCon presentation, but quickly, basically you need like a headers client. So this is something we'll be releasing sometime soon, but pretty much the Bitcoin network, the P2P network has been extended to add a few messages that also adds not just the headers, but also the Coinbase transaction and the Merkle proof for the Coinbase transaction, so that you could get miner ID stuff out of there as well. So to answer your question, yes, you need to connect to the P2P network. Right now, I know there are some other solutions like Zokin or whatever that try to also provide block headers on a different medium than the Bitcoin P2P network, but the simplest one is the Bitcoin P2P network. Will we have a template for P2P Bitcoin transactions with SPV? So the Bitcoin transactions with SPV, it's just if you follow the life cycle that we'll go through in a sec, it's just standard payments. The only difference here is the method of communication. So instead of sending the payment to the miners, you would send it directly to the recipient, and using the payment protocol, which is in many times called BIP 270. That's just the BIP number, but the payment protocol lifecycle, we'll go through that now. Has there been any work on figuring out the most optimum type of local peer-to-peer communication? Bluetooth, Wi-Fi, direct, something else? So yeah, there's been a lot of work on that in terms of like point of sale systems and stuff like that. So I would say the easiest method right now is just QR codes, and a lot of people, especially with the whole COVID stuff, have been really getting used to QR codes. So in terms of user experience, it's really simple. So and in terms of development, it's simple, really simple to implement. So this is how the life cycle works. But just to show you the video to remind you of how the user experience should look. If we could just go to the next. Yeah, so this is an example using Handcash and AnyPay. So basically, you would scan the QR code of the item that you want to purchase, and that would include the invoice as well as the endpoint. And then you would basically connect to that, fetch the payment request, and then you would get the payment request, craft the transaction, and send it back, the payment back to the recipient. The recipient would then clear that with the miners and then send you the acknowledgement. So if we can go through the life cycle. All right, so there's a question about P2P transactions via SPV. Do they work offline? So as the sender, they can easily work offline. You don't need access to the internet if you're the sender of the transaction. All you need to do is to have access to your UTXOs and to be able to sign for those UTXOs, and then so the recipient would be the simple way is a recipient would have access to the internet. The sender doesn't need to. This is the simplest thing. And in some cases, it's even possible for the recipient to be offline, but obviously that gives you less assurance. But in the end of the day, it all comes down to risk. There's no such thing as binary security. So it's all it's all a function of risk and costs. So if we go through the life cycle real quick, basically in the beginning, the customer wants to purchase something from the merchant, and this is where they create the purchase order. So this is like the basket of goods. For in the example we just saw, it's like the bottle, and then the merchant, once they know what the basket of goods is, they would create the invoice, and then on their end, and then display the QR code with the invoice there, and it will give you the endpoint for where to go and fetch the payment requests. And then the customer will scan that QR code or click on a link. So this first part is basically the service discovery, and so we're just going to go through the simplest service discovery, which is just using a QR code, but that can be extended with Paymail and other techniques. So this is how the QR code looks on the left, and what this just encodes is using the Pay protocol. It encodes a URL that includes the invoice. So this tells the customer to go to that endpoint and then download the payment request for that invoice. So this is what's happening in step 5. And when that happens, basically the merchant will first should basically get the policy quote, or the fee. Policy quote is just the next step after fee quote, and that will include other things that the miners will want to advertise other than the fees, for example, like the chain limit or anything like that. And then basically the merchant will work out the payment request, the outputs, the fees, and then return the payment request to the sender. So if you look on the right side, right now, the current version of BIP 270 doesn't include the fees, but we're actively working on extending that. It shouldn't be too difficult, but we'll discuss that in later slides. And then the customer will authorize the payment. And what that technically means under the hood is that they will add inputs to the transaction, sign those inputs, and then send the payment back to the merchant. And then there's been work on this SPV envelope that we'll discuss in later slides. It's been sent to the TSC. So it's with the TSC now, and there's a couple of people getting involved in that. So if you are interested, if this affects your business or your any person who's interested in getting involved, please reach out to the TSC, and we will. We will definitely, we need a lot of people to get involved in that, and make sure it fits all specifications. But in brief, what the SPV envelope is, it just packages a transaction as well as all of the metadata in order to be able to validate the transaction. And what that metadata is just the input transactions along with their Merkle proofs. And you can add extra data, for example, like mAPI responses and that kind of thing. And then the next step is that the merchant will, with all of that information, validate the payment transaction. So this fits into one of the questions around the headers. So you need the block headers in order to validate the payment transaction properly. So if you have the chain of headers, which you can get, it doesn't have to be on the P2P network. You can, for example, offer a service where you on one end, so this is some idea for some hackathon entries. So you could technically listen on the Bitcoin P2P network and fetch all of the headers and then serve them out on an API or something like that. And that's a completely valid way of getting the headers. It doesn't have to be on the P2P network. And then you would basically use those. You would just to validate those headers, you would just use the difficulty algorithm and make sure that the header is valid and it's on the longest chain. And that's how we'll go through validating the payment transaction afterwards. But that's basically how it would work. And then the next step is if the payment is invalid, you would reject it directly. If it's valid, then you would post a transaction to mAPI, to the nodes, basically through mAPI, and then make sure that the transaction is not double spent. And then you'll get a response. And with the new version of mAPI, version 1.2 plus, you would basically include your callback URL, and that's how you would get the Merkle proof. So you submit a transaction to the miner, and then when that transaction is mined into a block, the miner will call you back on the callback URL that you provided and give you the Merkle proof, or multiple Merkle proofs, because there could be multiple competing chains. And that's a normal part of how Bitcoin works. There are some reorgs sometimes, and it's completely normal. There's nothing wrong with that. And then afterwards, once you get the Merkle proofs, basically, then you would store those and then use them when you want to spend that UTXO afterwards. And the last final piece that's missing is the mAPI endpoints. So right now, the libraries that are available hard code a lot of the mAPI endpoints, but ideally the best case would be to get the mAPI information from the miner ID document. So the miner ID is it's part of the Coinbase transaction. So whenever a miner mines a block, they have their own Coinbase transaction, and that's a transaction that sends money to themselves, and they can include any data in there that they want. So historically, miners would just put random data in there. A lot of times they would put like some merge mining data or that kind of thing. and so miner ID is basically a way of putting data in there and signing it with a specific public key, and that proves that you are the miner that you say you are. In the past, there's been many instances where miners have tried to impersonate other miners to make it look like it's not them who are mining different blocks and stuff like that. So this is a way of miners making sure that other miners can't impersonate them or something like that. All right, some questions in the chat. Which mAPI endpoint accepts more than 25 ancestors? So that all depends on the miner. So I know with the latest version of Bitcoin SV node, the ancestor limit has been increased to 1,000. So any of the miners who are running that will have upgraded their ancestor limit from 25. And yeah, so my understanding is that Tal and Mempool and Mattercloud have upgraded. So you should check with them, but pretty sure that's the case. So another question is, will we have multiple Merkle proofs for a transaction, or is it just transitory until the next block is found? So yes, you may have multiple Merkle proofs for a transaction because you may have competing blocks. So let's say we're at block 0, and then you sent your transaction to get mined. So it will get mined in block 1 by one miner, but then let's say another miner mined block 1 prime, which is competing with block 1. Your transaction will be in both blocks, and you will have two different Merkle proofs for the same transaction, but they'll be in different blocks. Another question is, any chance you'll be posting a link to this following? Yes, we will. We will be posting this on YouTube. Yeah. All right, so basically, a lot of these tools we've been building, and so they're not fully complete. There are some missing pieces, and basically the idea is to try and get all the tools there so that we can properly do SPV and properly scale. So this is a big reason for the hackathon as well. We want people to use these tools and build on these tools as well. So with this webinar, we're just going to go through a lot of the tools that are available, and then you'll have to sort of link tools together, build on the tools, and we have a lot of work has been done in Golang around these tools. So check out, it's in my previous DevCon presentation at the end, but check out libsv on GitHub and check out Go Bitcoin SV. So there's a lot of Golang tools, and yeah, I'm sure if you go down that path, there's continued work on a lot of these tools. So that's a great place to start if you don't have access to using a lot of these tools. All right, next steps is the so this is going through the stuff we discussed before. This is the invoice creation. So this is Paymail stuff. So this is something missing on Paymail. So I explained this a lot more in the DevCon presentation. So if you want to check that one out, so we'll skip that for now. The next thing that is missing is the fees. So I also went through that. Basically, right now, there's no way to tell the sender how much fees that you require as a merchant, and it's always the merchant's choice to decide how much fees they need. So depending on when they need the transaction mined, they could choose different fees. So if you're a e-commerce merchant like Amazon or something, and you're not going to be shipping the goods before at least 2 or 3 days, you could afford to receive a transaction that pays less in fees, because that will take longer for your transaction to get mined and cleared, but you're willing to wait longer. But if you're like an in-store merchant, then you'd need the the customer to pay, the standard and like the amount of fees that most miners are charging, so that whichever miner mines the next block, your transaction will get included. So it's up to the merchant and the recipient to set the fees. And if this is why there's an advantage of the customer sending the transaction to the receiver, not broadcasting it to the network directly, because once you broadcast to the network, there's no way of recalling transaction. So you would send it to the merchant or the receiver, and if they are not happy with the payment, you're not sending enough fees, or you're not sending it to the right address or anything, they will reject it. And with BTC or something where the sender sends a transaction to the network first, there's no way of recalling it. I mean, on BTC you can replace by fee, but that's that's a whole other story. Anyway, moving on. There's also the SPV envelope. So that's in the process of the TSC. So contact the technical standards committee and try to get involved. And so basically, this is what's needed in order to validate a payment. So you need the payment transaction, the transactions that correspond to each input, and the Merkle proofs for each input transaction. So I've discussed that at length in the BSV DevCon. So maybe let's move on. All right, validating the payment as well. I discussed it in the presentation. So maybe let's skip on to the other slides. All right. Any more questions on the chat? Am I going too quick, too slow? Please let me know. All right. To get a clear idea of Bitcoin SV, so it is actually a project which helps you to interact with the kind of Bitcoin network, giving you power to analyze transactions and talk to miners. So is that an idea of Bitcoin SV, the blockchain, or in terms, are you talking about SPV? Okay, so let me just try and answer that question as I understood it. Bitcoin SV is just the original Bitcoin protocol. So if you read the white paper, you look at the original Bitcoin source code, it's all there. There's no surprises. This is like stuff that's been discussed at length in the early days of Bitcoin, and SPV is Section 8 of the Bitcoin white paper. So it just hasn't been implemented properly any time up until now. It's been very misunderstood, and I mean it's understandable because it's not easy to understand. It took me a while, even myself, to understand it. So that's why we've been working and trying to provide a lot of tools and examples for people. And if you also check out the Bitcoin Association courses, there's really nice courses that give you that go through the Bitcoin white paper and explain a lot of this stuff. And I think your question is more about mAPI, so we'll go through that now. So mAPI is an API that it's basically provides you a direct interaction with the miners. It's pretty much just an interface into the miners directly. So miners, the way they work currently is they connect on the peer-to-peer network to each other. So when a Bitcoin node starts up, it goes through the seed DNS, which is hard-coded in the Bitcoin node, and then it connects to different peers, and then the peers advertise the endpoints of other peers, and then it's just like a broadcast chatty network. And so if you are just a user of the network, it doesn't really make sense for you to listen on the P2P network and just get flooded with information. And it doesn't even, it doesn't make sense for miners to even send you that information, because you're not even going to need it. You're just interested in your transactions. Why do you need to listen to the rest of the transactions in the world? It's like if you want to use email, you're not listening to every single person's emails in the world. I mean, unless you're the NSA. And filtering out for your own emails. So this mAPI, it's for miners to advertise their endpoint, and the best way to do that is through miner ID. So you know which miners have been actually mining blocks, and they're not just listening nodes, and you can connect to them directly. And that gives you better guarantees that you're connecting to a real miner who's actually mining blocks, and they will be able to mine your transaction. So another question on the chat is, can I be a merchant with just being an SPV wallet, or is it just for the customers? Absolutely, yes. So if SPV is for any user that wants to use the Bitcoin network, you don't need a node at all. And a lot of people think even exchanges need a node. That's not the case. Exchanges can run perfectly well using just SPV. There's no need for them to download everyone's transactions in the world, and they don't need to do that at all, and it's just extra burden and extra cost. Another question. So basically the once we get into the SPV channel stuff, you'll be able to see that the customer and the merchant can have pretty much the same setup, and right now, I'll explain this later, but right now, in brief, most architectures work in more of a client server model, but anyway, we'll get into that later when we discuss SPV channels and IPv6 and that kind of thing. So let's go through mAPI. So you have a direct interaction with miners, a direct API. Miners can offer extra services. They can offer double spend protection notifications, and they can offer instant transactions. So you get guaranteed that you have better guarantees that a miner will mine your block. So you know that. So you get a response. You don't just send it on the network and have it get relayed to different miners. You have a direct interaction, and the miner has received it. You can get real-time notifications. So basically, once a miner has an API with their clients, they can offer whatever they want. And this has been a common mistake with Bitcoin. Actually, not just with Bitcoin, with anything. A lot of people think that security is a binary thing. And a lot of people think to make something secure, you need to make it impossible to be hacked. But that's just a huge misconception of security. There's no such thing as 100% secure. That just doesn't exist. If you want to make a system 100% secure, you just turn it off. That's the only way to have 100% security. And the only way to do security is it just comes down to risk and costs. You just need to make a system secure. You need to make it much orders of magnitude more costly for the attacker to attack the system than what they would get out of attacking it, basically. Another question in the chat. For me to build an SPV hard wallet, what are the basic tools I would need? The software package provided in N-Chain. Can the software package installed into a hardware as like a firmware? If I'm not making sense, please ignore this question. So basically, if you go through Samir, if you go through the life cycle diagram at the beginning of this presentation, and it's also in the BSV DevCon, you can go through and look at how the payment works. And if you check out PayD in libSV, it's just a dummy wallet, and it's pretty much just a SPV wallet. And then if you run that with going through the flow diagram, that's basically an SPV wallet. But that's the SPV wallet. There is more of a client server model, and I'll discuss that more when we get to SPV channels. But remind me if I forget. You mentioned block reorgs are pretty common. When I send any Merkle proof to the merchant, what guarantees him that I'm on the longest chain? All right, so block reorg are not pretty common. They're actually not common, but what I meant to say is that they're not something wrong. So it's not an issue if you have a block reorg. It's not an attack. It's nothing. But they're not common. They're not really common. So what guarantees them that I'm on the longest chain? So if you're a merchant and then someone sends you a transaction and you want to accept that transaction, you would broadcast it to the network. And then if there is a reorg, then all you need to do is make sure that your transaction is in both chains. So if there's a fork and then there's going to be a reorg, you don't have to worry about which chain is going to be the longest. If your transaction is on both chains, you're fine. So whichever one wins out in the end, your transaction is already mined. So you're going to have two different Merkle proofs, and all you need to do is wait for the race of the reorg to end, and you just know that your transaction has already been mined. Can I choose which miner will mine my transaction? You kind of, I'm not sure I understand the question, but basically depending on the miners, for example, fees, you can choose. So some miners will advertise fees at a specific rate, and some miners will offer lower fees. So if you send your transaction to both of these miners, and you didn't meet the first miner's threshold, but you met the second miner, the first miner is going to drop your transaction, but the second miner is going to accept it, and you know that they're going to mine it, but the first miner has dropped your transaction and they're not going to because you haven't paid enough. It seems I can build applications only related to transactions like wallets, payments. Am I right, or am I missing something? So the examples that we're giving is related to transactions, but that doesn't negate the fact that you can, instead of payments, use data, for example. So if you could have data published in a transaction, and then instead of sending that data to the mining network, and then have some sort of service like Matter Cloud. I know they offer like a subscription or some sockets to listen, and they listen to transactions, and if they have a op return prefix or something, they'll send you those transactions. That's the more expensive way of doing things. So you could more cheaply do it with SPV, and then have the receiver of that information basically have them the same way that the customer clears that on the blockchain, have them clear that on the blockchain, and then they know that it's on the blockchain, but they don't need to listen to the blockchain to get it. Everything in life is a transaction. Yes, I agree. So mAPI makes miners more competitive, offering different services. Yes, they can, for sure. And yeah, the idea of SPV is basically, it's not tough to make these transactions and scale if we do it properly. So the idea is the same way right now communication is really easy with the internet and everything. We want to make the same thing possible with payments. We want there to be like no sort of friction. The same way I can just communicate with anyone across the globe, send them a message instantly. There's no reason why we shouldn't be able to do that with money. And with Bitcoin is just a better money in terms of the friction there, and as in terms of the the soundness of the money. It's just it's much better money than anything we have available today. You could broadcast to the closest miner, and miners already will broadcast your transaction to the rest of the miners anyway. And if they offer double spend protection, if one of another miner has another transaction, different transaction, spending the same inputs, you'll get a notification instantly. So you should not be afraid of double spends. The tools are out there to handle double spends really easily. So don't even try to double spend. You're not gonna be successful. Could SPV wallets form a P2P network too among themselves? I see that miners can build network with that. Yeah, for sure. So that's also another idea for a hackathon. You could build a P2P network just for the headers. So that was something we considered as well. So that's definitely a good idea, so that you can have a user P2P network instead of a miner P2P network, and they would the same way that the mining network broadcasts all information, but all you need to do is broadcast the headers. All you need to do is have some sort of gateway between the miner's P2P network and this user's P2P network, just to get the headers from the miner network to the user's P2P network. And that's a good idea. So let's move on. The mAPI offers a bunch of API endpoints. If you go to the next slide, please. All right, I'll just keep talking until we can. It seems like we may have some technical difficulties, but I'll just keep talking. So anyway, basically, mAPI has different endpoints. You can query the miner's fees or policy and see what kind of fees they're charging, and then you could also submit your transactions to the miners. All right, yeah, okay. So there you have it. You can get the fee quote, and then you could submit your transaction, and you can query the status of a transaction to see if a transaction has been mined into a block, and how many confirmations and that kind of thing. All right, and this is the mAPI flow. It's pretty similar to the previous diagram, so we can just skip that for now. And it's on the mAPI BRFC and the reference implementation. So if you go to the Bitcoin SV GitHub org, you'll be able to see all of this stuff with much more detailed documentation. All right, and the JSON envelopes. So this is basically a way of signing a JSON object. So the issue with signing JSON objects is that JSON basically you can change the order of the fields, you can change the layout of how it looks, and obviously that's going to mess up your signature, because if you're signing something, if even one bit changes in that data, then you won't be able to verify it properly. So what this JSON envelope is trying to solve is to make the payload which you're trying to sign deterministic. And there's been some other projects in the space, like Universe without an I think, was recently released in the DevCon, which is very interesting. It does pretty much the same thing, but uses CBOR. You guys should check that one out as well. It's pretty interesting. And yeah, let's move on with that. This is the fee specification. So there's a fee specification on the Bitcoin SV BRFC's site, and that just shows you how to basically calculate the fee of a transaction. So the fee calculation of a transaction has to be deterministic, or else different people would be calculating the fees differently, and then that would cause chaos. So there's the DTFC, which is a deterministic fee calculation like algorithm and steps, and pretty much all you need to do is multiply the fees, the satoshis, by the transaction size, and then divide that by the bytes, and then take the floor of that, and then check if the answer is 0. Then and the fees are not 0, then the lowest you could pay is 1 satoshi. So that's the way it works. And miners can offer different types of fees. So they can offer different types of fees for data, for standard bytes, and in the future that will definitely get extended. I'm sure different scripts will get charged differently. We just haven't reached that point yet. But right now, miners are charging different standard fees and different data fees. So what constitutes data fee is any bytes after an output locking script with op return there. So any data in the locking script that starts with op 0, op false, op return, all of that is calculated using the data fee. So you can get cheaper transactions because miners can prune that information. All right, moving on. Okay, SPV channels. All right, cool. Okay, so if you haven't heard of SPV channels, basically they're just a sort of storing and forwarding mechanism. So the same way you have like email servers that will store your email and then forward them to you using POP or IMAP or something. SPV channels try and solve a similar problem. So if you remember the previous diagram, in order to connect to the receiver, they will give you their payment URL for you to fetch the payment request. But that means that they need to be always online. So that's completely doable right now, and a lot of services are doing that. For example, AnyPay and Handcash, they use that. It currently works today. But as we've seen, most of the internet, a lot of the internet still uses IPv4, and most of the devices are behind NAT. So it's not really easy to directly access someone on the internet. So we've done a lot of research around using IPv6 and things like CGA, cryptographically generated addresses. So there's a lot of interesting things that can be done when we get to that point. I don't expect us to get to that point anytime soon. So we're going to have to, make do with what we've got, which is why, we've been using things like the SPV channels. But if, once we get IPv6 out there, there's way much more address space. So with IPv4 right now, it's because there's not enough IPv4 addresses for the amount of devices online, which is why we use things like NAT in order to map on an internal network, in order to map from the internal network outside through the gateway router. But with IPv6, there's more than enough addresses for the entire world, and that way every device can have its unique IP address. And once you have that unique IP address, you could directly communicate with it. And using things like CGA, you could easily get IPsec in order to have confidentiality and authentication. So right now with IPv4, to do that, we use things like SSL. But in the future, once we have IPv6 that uses IPsec and that stuff by default, then there's going to be no need for TLS and /SSL. Craig actually has a lot of nice articles about that on his blog. So if you're interested in learning more, definitely check that out. But the idea with the SPV channels is to basically have like a broker that stores and forwards the messages to you. So what you would have is each participant would have their own channel server. So Shaders also gave a similar presentation a while back. So if you haven't seen that, check that one out as well. So the sender on the left would send messages into to the channel broker, which would then store it for the yellow guy. And then when the yellow guy goes online, they would basically get all of the messages the same way. When you go online, you get all of the messages on your email server. So it's pretty much the same idea. All right. So basically, the way this will work is you can have unidirectional and bidirectional channels. So with a unidirectional, you can only receive messages on that channel, or you can send messages on that channel. But with a bidirectional channel, you can send and receive on the same channel. So the Alice and Bob would connect to the same unique SPV channel and be able to send and receive messages on the same channel. So let me just check a couple of questions on the chat. How would an app or service place an identifier into a transaction such that people know transactions are from Weather SV? So, all right, that's a good question. So the way people do that nowadays is because most information in transactions is put using the op return opcode. So It's not the only way of putting data in Bitcoin transactions. Some people argue that it's not the best way, but that's what most people do right now. They create unspendable transaction outputs using op false op return. So if you have op false op return, that means you push op false to the stack and then op return. So that means basically the script is always going to be invalid. There's no way to spend that output, which is why miners can just prune that information. And the way people now identify different data in the transaction is right after the op return, they have like a prefix that specifies, whether SV or whatever sort of information that you want to put in that in that transaction. And a lot of services like What's on Chain or Matter Cloud basically categorize all outputs with specific prefixes differently. And if you're interested in that, there's been a protocol released by Unwriter called Bitcom, and it's basically a way to have unique prefixes by signing. So using like Bitcoin ECDSA public and private keys. So you can imagine if anyone could choose any sort of prefix, I could choose my prefix to be, let's say, I don't know, 001, and then, anyone else could use the same prefix as me, and, there could be collisions there. But Bitcom tries to solve that problem, and yeah. One way is to add op return. Yeah, that's exactly it. IPsec is better than SSL and TLS. Exactly. I think once we start using IPsec by default, there's no need for TLS or SSL. All right, let's move on with the SPV channels. So SPV channels components. So there's been a reference implementation which has been released on GitHub, the Bitcoin SV GitHub, and that's for the SPV channels like server. But for the hackathon, if you haven't already, we're running our own SPV channel server, and then you can get your username and password in order to use that SPV channels server. So all you need is to write the client that interacts and calls these different APIs, basically. And you can create a channel and then send and receive messages on that channel, and you don't have to be online. So you could do the whole SPV flow from the beginning of this presentation and the one explained in the BSV DevCon presentation. You can do it without always being online through SPV channels. All right. Best way to view Postgres data DB and Docker container of the SPV channel server command line. Is there a recommended GUI? So the best way, so I wouldn't recommend anyone to run the, you can use PG admin, but if you want to use SPV channels, the reason why we set it up is because we want you to use it as a client, not as the server. If you want to do some project using the server, then you run it yourself, but we make your life easier. We're running the server, and then you could just use it as a client, and you just call these APIs. All right, next slide, please. All right, yeah, so basically this is how the account registration works. So user request registration is provided with account ID. A service identifies its customers and users via accounts. So basically you have an account with the SPV channel server, and that's how you can have like a unique URL to send and receive messages on. You can specify whether your channel is a long-term or short-term and on your account. And then when you create a channel, you can then generate message tokens in order for people to send messages on that channel, and they need the message token or else it won't get through. And so if we didn't have message tokens, you would basically be able to get spammed on your channel. Anyone could just send you anything. So that's why you need to create a message token and then give the person you want to communicate with a specific message token. and then they could send you information. So basically what you would do is, if you're trying to do the SPV flow, if you're not going to run your own like payment protocol server in order to receive the transactions directly, you're going to have to listen behind like an SPV channel. And then so you would give the sender your SPV channel like URL with the message token, and you can put that in a QR code, and then the sender could scan that QR code and then basically try to fetch the payment request on the SPV channel, or basically try to or you could give them your SPV channel as the sender, and then have the merchant send you their payment request directly on that channel, and you could download it there and then send back the payment. So there's a lot of different ways you could do this. The easiest way obviously is presented in the beginning with the flow without using SPV channels. So both parties have to be online. Technically, the sender doesn't have to be online, but they have to be able to connect to the receiver. So the receiver has to always be online. But with SPV channels, both of them, they don't need to always be online. But the main thing that SPV channels solves is to have the receiver be able to be accessible on a unique like URL, without having them need to host the payment protocol server themselves. So using SPV channels, they don't need to host anything and run any server. So here Bitcoin Association is providing the channel server. So these are the steps. So you can send an email on hackathon@bitcoinassociation.net with your full name and address, and you get the credentials, and then you could log in. Yeah. All right, we can move on. A couple of questions. I saw mAPI JavaScript for SPV channel. Is it the client SPV channel? I'm not sure. SPV channel similarities with Lightning Network. So not really. So the Lightning Network is a way to do payment channels, and it's not the only way to do payment channels. So there's way better payment channels than the Lightning Network payment channels, which are Poon, DryJet payment channels. There's like Spillman style, there's Nakamoto payment channels, which are way better than the Lightning Network payment channels. And anyway, the Lightning Network is not even a layer. It's a separate network. It doesn't even need BTC. It could run on Litecoin. It runs on Litecoin. You could send a message. You could send a payment with BTC and have it received with Litecoin or whatever. It doesn't even need Bitcoin. And SPV channel, the only thing it tries to address is not needing the receiver. It makes it so that the receiver doesn't have to host their own server. So that's what SPV channels do. All right. Is there a way for us to access SPV channels app that Shaders presented? It's so if you use, so the presentation that Shaders gave basically uses SPV channels to receive a transaction, and it uses mAPI for double spend notifications. So all you need to do is just connect to SPV channels server, which we're offering, and then you just receive the transaction through the SPV channel, and then you connect to mAPI. So Steve's presentation was just a very like simple demo. What is channel encryption key pair? Is the client demo of SPV channels. So the channel encryption key pair is if you want to encrypt the communications over the channel. So I'm just a bit conscious of time because we've got 5 minutes left. So if we wanna, sorry, it took a bit longer than I expected, but it's good. We got a bunch of questions in there. So if we want to go through some of the SPV channels questions, we can continue with the slides, and just 1 sec. Okay, all right. I think we'll be able to continue. So here, here hackathon using one channel. So okay, we could go through this. Kapil, if you wanna also add to the SPV channel stuff, just let me know. And here, all right. Okay, so here's an example with Alice using a channel. So this is a bidirectional channel. So here, step one is Alice creates the bidirectional channel between Alice and Bob. And then after that, Alice creates Bob's message token so that Bob can also send messages on the channel. And then Alice sends Bob the channel URL and Bob's message token. So you could do that using the QR code. And then once Bob has the URL and the message token, they can send anything on the channel, and then Alice can pick that up whenever she's online. And then Alice could also write anything to the channel. So the way the bidirectional channel works is once you send messages on it with a specific message token, all other users of that channel with different message tokens will be able to download that message. It will get marked as read with your message token. All right, if we move on to the next. And we've got Alice and Bob. So this is the using two different unidirectional channels. So with this case, Alice would create channel 1, which is used to send messages from Alice to Bob, and then Alice would create the reader message token, and then Alice would also create the second channel and create the writer message token. And then if Bob wants to basically send messages on channel 2, they would need the message token, and that's how the two-way communication would work. Okay, and then Alice sends Bob his channel URL and reader message token for reading, and the same thing for writing on the other channel, on channel 2. And then Alice may write to channel 1 and read from channel 2, and vice versa. Why would you use 1/2 channels? What is the difference exactly? Yeah, so that's a good question. So basically, depending on the use case. So for example, if you want to have a short-lived channel, it may be easier for you to have like a bidirectional short-term channel in order to have like a payment. So you create a bidirectional channel for payments and to send and receive the messages on. And then for the unidirectional channel, you could basically have like a long-lived channel, and then if you want to receive messages on that, you would use the unidirectional channel for that kind of thing.
Yeah, I just wanted to give a hi everyone. I just wanted to give an analogy to explain this. So you can think of a bidirectional channel as a PO box that multiple parties can use, and the other case of unidirectional channels more as your email or mailbox, where someone else can send you messages on, again restricted by the message token or the access token that you have been giving it to them. So that's one way to think of it.
Yeah. I mean, there's so many different things you could do with SPV channels. So obviously, the first thing, it doesn't need to use Bitcoin. It's just a way of storing and forwarding messages, the same way like email does that kind of thing. But the thing that we're trying to solve is having the receiver not need to host their own server. And that has a lot of implications with SPV. So right now we could easily do the SPV flow. So the SPV flow that we went through in the beginning of the slides, that's completely possible, and it's being done right now with Handcash, AnyPay. We have examples on libSV that can do that. We've done a couple of demos. It's pretty easy, but the harder thing is to use like SPV channels and everything else there. So I'm sure, and the idea is we've got like a lot of these different tools, and for the hackathon, the idea is for you guys to sort of fit those tools together and build on top of them. And I'm sure if someone created the whole end-to-end flow with SPV and SPV channels, I'm sure me and Kapil can try and convince the the judges to give you the first place if anyone could build that, but in Golang. So make sure you do it in Golang if you're gonna do that. Another question is, will the SPV servers be DOSed? Kapil, you wanna answer that
one? Not really, because it's only possible if you. So the first step is you need to have an account, and that is something we are monitoring and restricting, and only limited access is given. Again, when you create a channel and then use it for any purposes, then also someone who is either writing or even reading, they need to have a certain message access token, and with only that anybody can access. So there are limited possibilities to get DDoS.
Yeah, and anyone can run their own SPV channels like server or broker. So any other good links we can exploit before you go?
I just have one thing I wanted to add on one of the very earlier question that was asked regarding where can I get block headers. So you cannot download all block headers for the blockchain, but if you look at what's on chain APIs, they do provide limited capability in terms of getting block headers. Of course, you can get a specific block header anytime using that API, but also can download last 10 block headers using one of their API. So do check out their API collection. It's there in Postman as well.
All right. What would be an example of leveraging SPV channels and mAPI? What would be an example of P2P not only being payment transactions, but any indirect interaction between participants on the BSV network? Okay, so leveraging SPV channels and mAPI. So the example we went through in the beginning of the slide, that obviously uses mAPI when you want to broadcast something to the network. But it just wasn't using SPV channels. So if you do the whole flow, life cycle, but using SPV channels in terms of the communications, that would be an example. But that would be using payments, and asking for an example without being payments. It could be done for specific data. So let's imagine the case of weather SV. So right now, if you want to put weather SV data on the blockchain, you would create transactions with the weather SV like prefix and then the weather SV data, and then you would just broadcast that to the transaction to the network, right? But with this case, you could send it to the weather SV sort of server, and then the weather SV server would then get that settled on the blockchain, and then have the weather SV server store all that data and have it settled on the blockchain. And then then the weather SV server or servers don't need to listen to all of the transactions on the Bitcoin network and filter for weather SV data. So this is a much cheaper way of doing it. So obviously it doesn't. You can still send the transactions to the network and then have a server that filters for that information. A lot of use cases, you want different people to be able to send data, and you don't want to have a server or servers to be like an intermediary there. So you want it to be a completely open. Not that this SPV way makes it not open, but it just makes it much cheaper, because you don't have to have this intermediary that or you don't have to listen to the blockchain. So you could send it directly to the server and have them settle it on the blockchain. and you could get like a Merkle proof for yourself and make sure that it's there. So that's an example of doing it using P2P. It's gone quiet. What would I build? Honestly, I think the whole idea is to try and get SPV done properly. It's been a long time, and no one's really done SPV properly. There's no sort of real like service. If someone built SPV now, it's more like an open source sort of thing. You can't directly sort of profit off of it, because it's just like libraries. A lot of the wallets right now have their own like bespoke solutions. A lot of them are doing things that are not necessarily the most efficient way of doing things. And as we've seen, because the Bitcoin network is not really is not really at the point where it's at the level where it's really what's the word, like has a lot of data on there, and not mature. It's not reached. So there's blocks are really small. It's not reached the point where blocks are really big, and services can't handle it. So that's why users are not feeling the pressure. But as soon as blocks get big and there's a lot of transactions, the only way to keep up is to use SPV. So a lot of these like bespoke solutions where people are sort of doing things in not the best way, they're going to start falling over. And we've seen it with a lot of stress tests on mainnet. As soon as we have some stress tests, some services start falling over, and that's not an issue with Bitcoin at all. It's an issue with the way a lot of these services have set up their code and their systems. And so a lot of these services have not reached that level, and a lot of some of them still run nodes and stuff like that. And it's not the right way to it's not the scalable way to be doing things.
Right. Yeah, I can add one more thing.
Go for it.
What would you build? So just on the top of my head, there are two things. And in the first slide of channels, we described usage of Paymail. So Paymail is, again, it's not a complete Bitcoin thing, but it's a service discovery which is trying to replace complex Bitcoin addresses. So think of that as the email identifier, and channels as your IMAP server and messaging infrastructure. So that could be one idea to exchange payment between two people using that infrastructure. Another good idea is just build an SPV wallet. That's something, again, quite interesting.
A couple of things. Let me just add this link as well. This is just a really simple wallet that we've been using to test a lot of the SPV stuff. But some things that are missing, and if people want to get involved and add to the stuff, it's the script validation. So in order to validate a payment, you need to run the script validation engine that's in the Bitcoin node, basically. So right now, most transactions are really simple. They're like a pay to public key hash, and the script is just op dupe, the hash, op equal, op check sig, and that's really easy to verify. But once you have like a script that's complicated, the script stuff, and someone sends you a transaction, how are you going to validate that? There's not that many libraries that validate those scripts. So there's actually there's people that have been extracting that code from Bitcoin node and we have some of that in C++, and I don't know if there's other libraries in other languages that have something like that, not that I've seen, but something we were planning on doing is getting the from a project called BTCD. So that's a Bitcoin node written in Golang, and so right now it's being used on BTC for Lightning Network. So they use that with LND, which is a implementation of the Lightning Network node, and they use that library a lot. So the BSV fork of that library is not being used by anyone because the BTC node is completely single threaded, and it's not anywhere near the right standard to be able to run on the BSV network. So no one's actually running that anywhere on the network. So it'd be a shame for that code to not really get used. But it's actually one of the most documented codes that I've seen. So an idea would be to extract the script validation engine from that, or any other sort of library to have script validation, because that's an aspect of all of these tools that's missing. So that's something I would definitely look into. Some other questions in the chat box. Going back to a hardware component that can function as an SPV wallet, from the firmware standpoint, can I use the SPV libraries? So yeah, definitely. Once all those libraries are out there, you shouldn't need much. It's really easy to do a lot of the stuff. Even the headers client, it's in there. It's right there in the white paper. So every single Bitcoin header is only 80 bytes, and you're going to be getting 80 bytes every 10 minutes on average. So that's like megabytes of data in the worst case, which is nothing, and that could fit on any sort of Raspberry Pi or any small device, and definitely really easy to get on some sort of hardware component like a Raspberry Pi or Arduino or something like that. Anything you want to add there, Kapil?
No, I think that's fine.
Sure. You want to take the next question?
Yeah, I'll do that. It seems like there need to be a SPV wallet library, as current wallet apps are not innovative in this direction at all. Yes, that's a valid statement. I think so. Overall, as Jad mentioned earlier in his presentation, SPV has been the most ignored part of blockchains till now. Nobody was looking at user node being actually not really a real node which does any mining, or they don't perform any consensus operations. And it's one of the things that is also described in white paper, that SPV is what users need to use, not the actual mining node. So that's why these user clients or user nodes, whatever you want to call it, these SPV nodes, they play a very critical role in scalability. And so a wallet library around it, yes, that will be a very innovative product, or I think the ecosystem needs that. So definitely a good idea.
Yeah, definitely. A lot of the people in the space have sort of neglected that because it's not a way to directly easily monetize. So that's why it's been. But that doesn't change the fact that it's really needed, and a lot of wallets are sort of just doing it internally and not publishing it. And so definitely like a library is a good idea, and that sort of fits in with the next question that is about. It seems like the future is an SPV wallet per app and not a wallet app that other apps on the same device talk to. So that fits in with the library. So if you take a look at all of these components, like creating an SPV wallet is very lightweight. It's not really difficult to do. And I would say in the future, wallet apps will do a lot of the stuff that sort of modern banking apps do. like categorizing your payments for you and doing a lot of the user experience kind of thing. But in terms of needing wallets to do SPV and all that stuff, nowadays a lot of the wallets do that stuff for you, but it's really easy. Once all the tools are out there, you could easily put a Bitcoin wallet on any tiny IoT device, and that's the plan. We want everyone to use Bitcoin and make it extremely easy. The same way you can easily communicate with anyone. I want to be able to just send and receive money really easily anywhere across the globe and instantly.
I think the next question I can take. No, there is currently no SPV wallet as discussed in the white paper that exists. I know there have been a couple of attempts. It worked, and then I guess, as Chad mentioned, it's not so easy to monetize, so it didn't really got in a mature state. But at least I can say from Bitcoin Association side that we are working on something that will fill this space. Not, I mean, we are not going to solve a user problem, but we'll provide the right tooling for people to build it.
Yeah, I mean, to be fair, it's just like a tiny paragraph in the white paper, so it's it's not the most comprehensive explanation of how SPV would work. So it's understandable that it's taken this long for a lot of people to understand SPV and properly implement it. And especially with a lot of the way we've been doing things with the legacy way of doing things, like the way BTC still does things, it just flips the whole model on its head. And P2P payments were there from the start. So if you look at the initial implementation of Bitcoin, there was IP to IP transactions, and then Satoshi mentioned that if you weren't able to connect directly to the receiver, then you could send a payment to their address and have them fetch it off the network, but not as the default way of sending payments. So and because it was hard to make it secure, then people just defaulted to the second way of doing things, and it's not the best way of doing things, for sure. Yeah, that's a good idea, Brad. I mean, I'd love if it was in Golang, but
I'll pass on the idea to the team. Yeah. Thanks, Brad.
Why is Golang so desirable? Well, I wouldn't say. I mean, I would say it's because at least with my personal experience, I spent quite a bit of time with JavaScript and doing a lot of this stuff. It's obviously easier to use JavaScript for a lot of this stuff, but once you get into Bitcoin stuff with bits and bytes and doing things at a scalable level, it just I didn't enjoy doing it with JavaScript at all. I think Bitcoin. I think Golang is a much more suitable language for a lot of Bitcoin stuff. So obviously, there's no such thing as a better language. All different programming languages have their pros and cons, and are useful for different use cases. But I would say for doing Bitcoin stuff, especially low-level Bitcoin stuff, Golang is my preferred language, and there's already a lot of tools in Golang for Bitcoin. So it's better to build on a language that's already got a lot of stuff there. And trying to move away from JavaScript, especially for doing things that are stable and scalable. Yeah.
I do want to mention one thing, I think, till we are waiting. But in DevCon, there was a presentation made by Electrum SV regarding running a reg test environment reg test blockchain. So if you are interested in for your local development, you can check that video out. It has the complete instructions on how to install and run it.
Yeah, that was a good presentation, and what they're trying to have like a whole setup environment similar to Ethereum's like Truffle and Ganache sort of suite for Bitcoin, so you could basically test out your wallet without having to run it on testnet or something. You could just run it on the reg test with all of the tools there, including mAPI, miner ID, the headers, client when it gets released, and all that stuff.
You can find their SDK on their GitHub page. So Electrum SV GitHub.
Yeah. And Peter P from YouTube asks, is SPV hard to do? It's not hard to do. So the initial flow that we went through in the beginning of this presentation, that's extremely easy to do. And if you look at PayD, for example, it's just a dummy like wallet example that basically does the whole flow that we showed in the beginning. It's really easy to do. And there's not much documentation on there, but we'll look into adding some documentation there. But it's really easy to do that if the receiver is hosting their payment protocol, the BIP270 server themselves. It's extremely easy to do it. Like it will take you like a day of work, and you could easily do it. But the harder part is to use SPV channels, because you don't always want to host your own server if you want to receive payments. So that's what SPV channels helps, and that's a bit more difficult to do. I want to say it's hard, but it just takes some more time. But the simple one where the receiver is always hosting their own server, it'll take you like less than a day to do it really easy. Right, we've gone like 25 minutes now. All right.
I guess
any more questions? Someone's typing last minute. All right, you're welcome. Yeah, hopefully we could get some more SPV tools out there, and hopefully soon it'll be a solved problem. We don't have to. I feel like I'm always talking about SPV. I want to stop. So.
Yes, let me just send the DevCon. I think it's in day 2. That's the link I've sent. But if it's not in day 2, it would be in day 1. You can have a look at it. All right. I guess we can conclude.
All right. Thanks, everyone, for joining today's webinar. And I look forward to seeing the output in the hackathon.
Same here. Looking forward to see your entries. Thanks, everyone, for joining in.
Thank you.